So we're going to talk about a little experiment here. Are online SAT prep courses effective? Okay. So a high school regularly offers a review course to prepare students for the SAT. This year, budget cuts will allow the school to offer only an online version of the course. Suppose the group of students who take the online course earn an average increase of 45 points in their math score from a pre-test to the actual SAT test. Can we conclude that the online course is effective? This experiment has a very simple design. A group of students, or a group of subjects, which are the students, were exposed to a treatment, which is the online course, and the outcome is an increase in math scores, which was observed. Here is the design. Okay. A closer look showed that many of the students in the online review course were taking advanced math classes in the school. Maybe the students in the online course improved their math scores because of what they were learning in their school math classes, not because of the online course. This confounding prevents us from concluding that the online course is effective. Okay? How can we make this experiment better? Anyone have an idea? What do you think, Ginger? Okay, you could do all like people who didn't take advanced math. Okay, what else? Donovan? Don't let them go to math class. Okay, it might be a little unethical. None of you have like a super great idea. How about another idea? Yeah? Okay, okay. So all the combinations, okay. What else? What about the fact, remember we talked about something yesterday, yeah. That's true, have a control group, right? So have something to compare to. There's nothing to compare to, right, on this one. What did we talk about yesterday with the women who were taking hormones? You guys remember? What was like the big deal about that? Why it was a problem? What do you think? Yeah. Did these kids like get a pick? These kids chose on this one, but that actually doesn't help us, right? We didn't tell which kids what to do. And so the fact that they chose to take it means they cared a lot more too, right? Okay. So the remedy for the confounding in the SAT prep course example is to do a comparative experiment. So we should write that word down. Okay, we need to compare, in which some students are taught the SAT course in the classroom and the other similar students take the course online. So instead of comparing to taking it or not taking it, we're actually going to compare students who take it in the classroom and students who take it online. Most well-designed experiments compare 2 or more treatments. Okay, so you have to have something that you're comparing to. All right, in an experiment, random assignments means that experimental units are assigned to treatments using chance process. So this is what we talked about. What if we just took all of the juniors and we said, you're taking the class, you're not. You're taking the class, you're not. Or you're doing the online class, you're doing the classroom class. Okay? So that's random assignment. And hopefully you have enough people that it sort of weighs out the fact that some people are in advanced math classes and some aren't. So you don't necessarily have to split them up by groups. If you do a random assignment, hopefully those things balance each other out. All right, so this year the high school has enough budget money to compare the online SAT course with the classroom SAT course. 50 students have agreed to participate in the experiment comparing the 2 instructional methods. So problem, describe how you would randomly assign 25 students to each of the 2 groups. So we've talked about how to do this, right? So we're just assigning 25 kids to classroom group or to online group. What are the 3 ways you can do it? Hat method, random integer on your calculator, and the table. Okay, those all work. But easiest way, and the way that you guys, I like recommend you do it, is the hat method. All right, hat method actually probably you guys will mess up the least on, right? It's just pretty like obvious how to do hat method. So to do it, you guys first would have to say, I'm going to write everybody's name on a piece of paper. I'm going to put it in a hat. I'm going to shuffle it up, and I'm going to draw 25 students, and the first 25 I draw are going to take the online, and the rest are going to take. Okay, so whatever way you do it, though, you have to explain clearly. So just what we went over on that quiz, I don't want to go over every single one of these methods. It's basically what we just did, where I talked about how you have to remember to label. You gotta ignore repeats if you do this one. But on the slips of paper one, that's probably the easiest way, and you'll probably mess up the least. Yes? I guess that'd be a good idea. Identical, like you're not going to have bigger sizes of slips than another, but it's usually kind of a given. So I don't know. Does it say that on this one? Nope. Put the slips in a hat. You don't have to specify. It does say that? Oh, yeah. Identical slips of paper. All right. So, yeah. I guess I see that as a given, but sure. All right. We need a control for some things, okay? So this is another word that you want to think about is the word control. Some things you can control. We must ensure that the only consistent difference between the groups during the experiment is the type of SAT prep that they receive. So some things we can control for. Give all students the same pretest and the same actual SAT test at the same times on the same days. Okay, that's going to be more fair, right? If you give some of them in April and some in May, that's not going to be as fair, given you might have learned more. So control for things like that. The length, timing, content, and instructor of the prep classes should be the same. Okay, if you switch teachers, that might make a difference, and then you have confounding. So you're going to try to keep a bunch of things in control, those things that you can keep in control to prevent confounding. Hey, if I just put one student in the SAT online course and one student in the classroom course and compare how they do, is that a good experiment? No. Okay, one kid might just be smarter than the other one and do better. So this is a new word you want to add to your vocabulary list as well. This is called replication. Use enough experimental units to distinguish a difference in the effects of the treatments from chance variation due to the random assignment. Okay, so if we have enough people, then hopefully we have some of the smarter kids and etc. kind of evened out, right? Or the kids in advanced classes evened out. All right, so we want to write down the 4 principles of experimental design. So you have to have these 4 things in order to have a good experiment. Number 1 is comparison. So you want to compare 2 or more treatments. Number 2 is random assignment. You want to use chance to assign experimental units to treatments. Don't let them choose whether they're taking the online class or the in-class one. So that way we get roughly equivalent groups, and we're balancing out the effects of other variables. And then we need to use control, where we keep other variables that might affect the response the same, like taking the test at the same time, having the same instructor for the in-class version. And replication, using enough experimental units in each group so that any differences in the effects of the treatment can be distinguished from chance differences. All right, so why is control important in an experiment? So let's say that we just let the number of class sessions, let's say we let them like choose it. So over here, students could pick how many times they attended the class or how many times they like got online and did the class. And over here, the number of class sessions stayed the same. So notice here we can tell a big difference or a significant enough difference to make a statement about it. So this is the people who took the classroom, their dot plots. And these people here are the ones that took the online course, and so they're definitely higher than the ones who did the classroom class. Whereas over here, if we let them choose how many times they attend, it kind of makes it a little more confusing to make a statement. Some people did do really well. They probably went and took the class a whole bunch of times, right? Some didn't do as well. So it's a little more spread out, and it doesn't help us make a conclusion at the end, okay? Yes, Jake. Well, as long as you're forcing them to attend a certain number of classes, it probably doesn't matter. you know, like as long as you're saying everybody's going to 5 classes. Yeah. All right. Physician's health study. So this is a well-designed study. Does regularly taking aspirin help protect people against heart attacks? The physician's health study was a medical experiment that helped answer this question. In fact, the physician's health study looked at the effects of 2 drugs, aspirin and beta-carotene. Researchers wondered whether beta-carotene would help prevent some forms of cancer. The subjects in the experiment were 21,996 male physicians. They're all doing the same job. There were 2 explanatory variables, also known as factors, each having 2 levels. You either take aspirin, yes or no, or beta-carotene, yes or no. Combinations of the levels of these factors form the 4 treatments shown below. 1/4 of the subjects were assigned at random to each treatment. So we did every combination, okay? All right, on odd number days, the subjects took either a tablet that contained aspirin or a dummy pill that looked and tasted like the aspirin. So it's important, you guys might want to make note of that. That's called a placebo. Do you guys remember that? I'm sure you've heard of that, but so that way they don't know. So they had no active ingredient. On even numbered days, they took either a capsule containing beta-carotene or a placebo. There were several response variables. So they looked for heart attacks, different kinds of cancer, other medical outcomes. After several years, 239 of the placebo group, but only 139 of the aspirin group, had suffered heart attacks. So this difference is large enough to give good evidence that taking aspirin does reduce heart attacks. It did not appear, however, that beta-carotene had any effect on preventing cancer. So the problem, explain how each of the 4 principles of experimental design was used in the physician's health study. So the first principle is comparison. So anybody want to tell me how they used comparison? Ginger.
They compared the effects of beta-carotene and aspirin.
Okay. And the next one is, what's the second one, you guys? Random assignment. Owen, what do you think? Random assignment, what'd they do? I have no idea. Charlie, what do you think? Yeah, they were assigned, right? They didn't get to choose. They were randomly assigned. It's pretty hard, yeah, okay. And Maddie, what's the next one after random assignment? Okay, controlled. The things they controlled for. Anyone have an idea of what they controlled for, Jake? What day they took which pill? What else? I thought it was interesting. They actually had them all have the same job. They were all physicians. So that was kind of interesting. All right, and the last one was replication, which is using a large number of people. They had like almost 22,000 people, so that's pretty good. All right, so let's make sure we did that right. Comparison. Researchers used a design that compared both of the active treatments to the placebo. Okay, random assignment. Yep. It was used to determine which subjects received each of the 4 treatment combinations. This helped ensure that the treatment groups were roughly equivalent. Control, they have, same gender, same occupation. All subjects followed the same schedule of pill taking. Replication, over 5,000 subjects per treatment group. So this large number of subjects help ensure that the difference in heart attacks was actually due to aspirin and not just chance variation. All right, in a completely randomized design, the experimental units are assigned to the treatments completely by chance. We basically already used the words, but now it's just changing it to completely randomized design instead of the random assignment, but those mean kind of the same thing, okay? All right, so conserving energy. Many utility companies have introduced programs to encourage energy conservation among their customers. An electric company considers placing small digital displays in households to show current electricity use and what the cost would be if this use continued for a month. Will the displays reduce electricity use? One cheaper approach is to give customers a chart and information about monitoring their electricity use from their outside meter. Would this method work almost as well? The company decides to conduct an experiment to compare the two approaches. So they either get a display, which costs more money, or a chart, and they're comparing with a group of customers who receive information about energy consumption, but no help in monitoring electricity use. Describe a completely randomized design involving 60 single-family residences in the same city whose owners are willing to participate in such an experiment. Write a few sentences explaining how you would implement your design. We are going to read through this, you guys, because you're going to have to do these, and it's probably more than you think, some of them. So this person or the book actually made like a picture diagram for us. So we've got 60 houses, and then we randomly assign 20 houses to a group. And we've got treatment 1, which looks at the display, treatment 2, which has the chart, and treatment 3, which has neither of them. So it's just a control group that we're comparing to. And we're comparing electricity use. So this is really nice and all, but you actually can't just do that. You don't have to do this either. You actually have to write it out and explain it. Okay? So to implement the design, start by labeling each house with a distinct number from 1 to 60, right? So we have to explain this. I know it seems repetitive and we've done it a bunch of times, but you do want to explain. Write the labels on 60 identical, so I guess we do need that word, identical, you guys. Slips of paper. Put them in the hat and mix them well, draw 20 slips, and then explain what you're going to assign, okay? All right. Was a control group really necessary? Yes. And the reason that it is because last year's temperatures could have been more extreme, so you can't just compare to last year's. And many households might show a decrease in electricity use, but we couldn't be sure whether this change was due to the weather or to the treatments. Okay. All right. Last part. Music students often don't evaluate their own performances accurately. So can a small group discussion help? The subjects were 29 students preparing for the end of the semester performance. That is an important part of their grade. The 15 students in one group each videotaped a practice performance, evaluated it themselves, and then discussed the tape with a small group of other students. So the first 15 did a small group. The remaining 14 students watched and evaluated themselves. At the end of the semester, the discussion group students evaluated their final performance more accurately. All right, so it already tells us that if you had a group, your performance was more accurate to your actual one, okay? Describe a completely randomized design for this experiment. Write a few sentences describing how you would implement your design. So we've done this a lot. Jet, how would you do your completely randomized design? Hat method, okay. What do you have to say first? Okay, good. All right, good. 15 of them could be small group, 14 of them are alone. Okay, good. What's the purpose of the control group? Let's go, Dem. What's the purpose of the control group? Yes, right. The purpose of the control group is to provide a baseline for comparison. Without a group to compare it to, it's impossible to determine if the small group treatment is more effective. How would we know? Okay, and that's it.